Hello. Now let's do it one more time. Hello. Okay. So I want to talk to you about moldable development, which is a new way of programming. But before we do this, who's heard of moldable development? 1, 2, 3. Okay, not that many. Excellent. So you're in the right place. My name is Tudor Girba. I am the CEO of feenk. At feenk, we modernize legacy systems. We love working with legacy modernization. And the way we do it is we actually make systems explainable. We make them enjoyable. And the way we do it is through moldable development, which is programming through custom tools. Before I explain what that is, a few questions. So how many of you are developers here? Excellent, pretty much everybody. If I say that you spend at least 50% of your time reading code or other similar textual artifacts, would I be correct? Raise your hand. Pretty much everybody. Okay, one more question. When was the last time you talked about how you read code? Not about the code you read, but about how you do the reading. Let's say last half a year. Anyone? And the conversation with me in the lobby, they don't count. Okay, so not many people. A few, right? Now, here's the problem with that. You don't talk about it, it's not explicit. It's not explicit, it has never been optimized. And this is your single largest expense. Now, when we say we want to program through custom tools, we mean that we're going to build tools specific to some situations. But the question is how many? I mean, how many of you have used plugins in your development tools? Exercise is good for you. Come on. Excellent. Pretty much everybody has used that. But that's not what I mean. I mean thousands of custom tools. Not a few custom tools, thousands of them. But actually, that's not exactly what I mean either, because I mean thousands of custom tools per system. Now, who thinks that's odd? Excellent. So, why do you read code? Anybody? Why do you read code? Somebody here says, I read code to understand. Anyone else? Because you don't understand, exactly. So any other description? Is it, for example, this understand thing, is it the same as I would read a textbook on astrophysics? I would also might want to read that one to understand, but is it the same kind of understanding? No. Any other, what kind of understanding is it? To change. That's interesting, because that implies that the goal isn't to read, the goal is to make a decision. Now, so who is recognizing what this is? No, oh, come on. How many of you have been at the keynote of Simon Wardley? Okay, that's a Wordly map. I'm going to use a Wordly map to explain what moldable development is. So for those that maybe need refreshing, things move from left to right, Genesis, custom build, product, commodity, and then they move. Once they go to the right, new things appear and pop up on the top left, and you go. The visibility goes from top to bottom. So regardless of whether you're in engineering or you're in a business, if you want to make a decision about the system, that decision must be somehow related to the system, because the answer is right there. And that's why you're thinking, oh, I need to read, because this is how I will inform that decision. Right? Okay, now reading happens to be the most manual possible way in which you can do this thing. Now, we assume here that people don't have too much time at their disposal. Like they can't throw away, let's say, 4 hours per day just because they don't know what to do with those, right? Is that okay? Is that a correct assumption? Okay, excellent. So the question is, what can we do with this energy that you're spending? Because this is your single largest expense you have. So what can we do? Let's go deeper. And that's the interesting thing. The beauty about mapping is that it allows you to describe things, go a little bit into the details, things that you might not see if you don't think about it. So let's go and talk about it. So we say a decision requires some sort of an assessment, which is basically the process of understanding something enough to inform the decision. Now, the assessment requires an exploration. So I need to go and explore, which, of course, is based on a conversation. And now the conversation is either between people or between people and computers and systems, which are actually more interesting. And we'll see why. Now, of course, the conversation must be informed. You need information for that. But you need to extract information somehow from the system. But here's the thing. You cannot experience anything in a system except through some sort of an experience. There is no way for you to see anything in a software system except through some sort of a tool. And now, today, if we look at how decisions are being made, and we get the luxury of being exposed to all sorts of situations, because we go into companies and we get to see typically hard problems that people have maybe tried and failed, and they don't know what to, they cannot wrap their hands about how they could possibly go about fixing those. And so what we notice is that lots of these assessments are gut feel driven. We think it's like this, we feel it's like that. And that is because the exploration is rather ad hoc. There is no systematic way in which one goes from a problem to finding a solution. The conversations, they do have data points. Data points do exist in the PowerPoints or in the documents, but the question is which data points? And that's important. Now, before I explain how this one goes further, let me give you an example. So I'm going to go here in the assessment, and I'll tell you a story about a data pipeline. So this was a data pipeline which is rather central or important for this organization, because it was the main marketing pipeline that was sending offers to a significant amount of customers of this organization. And the issue that they noticed was that going from left to right of this pipeline took about 1 day. And so they saw that this is a very big problem. So from the moment they had the information as to how they should react to the market, until the moment they could go into the market, there was always a delay of 1 day, and then for them it was a particular problem. All this problem was visible all the way to the board. So there was CIO-mandated initiative to make this, to improve this one. But the problem was that 3 years later, and a significant amount of people working on this, the data pipeline took exactly 1 day to go from left to right. And the question is why? This was not a lack of budget, it was not a lack of will, it was not a lack of energy spent. So what was the problem? So we took a look at this, and we said, well, can you describe to us how that pipeline is? And this is what they drew on the whiteboard. They took a pen and they drew it on the whiteboard. And we said, okay. And we said, well, in order to reason about this, we're going to try to analyze this. What kind of data do you have about these pieces? Well, it turned out that the thing on the left was a homegrown Excel-based language that was transforming the Excel files into instructions that were being actually used to run transformations over the database. And after this ones, they said, well, it goes into these databases, Oracle for some part of the data, Cassandra, now SQL for another part of the data. Now, of course, we got the DDLs, we got the Excel files from the internal system. And then we had there Cassandra. Of course, you get the descriptions of that, but it's not so useful. So what we did, we instrumented the whole database for a day, and then we could extract it, because this was the cycle of the company, so we could have a pretty good idea of the schema of the data that went into it. And then on the other side, at the end of this, was a low-code platform. one of those that was advertised as being, write code fast. And they did write code fast. They had 22,000 scripts in 54 different templates. And the only way you can export that one was through an XML file that was barely readable. So this was the input that we said, OK, let's take a look at it. Now, here's the issue. You can't read your way through this. I mean, you can, but we don't have enough time. So how else can we approach the problem? Where are we going to build the tool? So we started to build some tools, and then we looked at the output of the internal, and then we compared with the schemas that we got in the database. And then we went back and said, well, they don't really match. Are you sure that there is no system right there in between, something that you might not know of? And lo and behold, they found the whole system. Now, it would seem, what? Well, this was an external system, which was kind of a black box that they could send us the CSV files with the flow that was happening, between the input and the output. Now, after they gave us this, we could produce this. The details here, they don't really matter, actually. But the point here is that we can see the source columns here, and we can see how they were transformed along the way. And you can see that here we have about 600 of them that are being used afterwards, and 900 of them that are not used at all. So this was their hypothesis. Do we have any extra data that we're generating along the way that we don't know, maybe we don't use afterwards? And then it turns out that they did, and there was quite a bit of it. Now, of course, the problem was that you cannot choose, you cannot make this choice of whether or not this data, you can remove it by just looking at the box on the left. You have to have the full idea of the data pipeline. And so, the same thing, the question is, how did we produce the picture here? And the picture is actually not manually produced. It's produced by a tool. And this was by actually being able to follow how every single attribute flew through that pipeline. Oh, this is called data lineage. Well, here's the thing. We were not specialists in data lineages. We just said, here's the information that we need, and we go, what is the interesting tool to build? And then we said, OK, we're going to need that tool, and we built the tool. Now, here's the thing. This is actually not a data lineage problem, because in order to understand how things flow within a transformation, you need to go in, first of all, understand the language. You also have to go and we had to reverse engineer both the language on the left and the language on the right in order to do that and understand how the control flow there works. And so once we have something like that, once we have the little pieces that you see here on the right, I can produce the overview on the left because it's just a derived picture. And that's the key, and that's the idea of moldable development. It is, how do we go from something that we have to believe in into something that we can check directly? The picture that was hand-drawn ideally had to match, they had to enumerate 5 things. They could enumerate 4, so they had 80% accuracy, even at that high level of abstraction. And the problem with any picture that you're drawing about your system is that if the picture depicts the current system, it does not document the system. It documents your belief, the belief you have about the system. And that beliefs are not interesting inputs for decision making. And we can fundamentally change that because it's already difficult enough to design and construct interesting systems. But not knowing what the current system is absolutely not an aggravation that we actually need. Okay, so now, so this is how an assessment can look like. And that's actually a completely different world. Because we did not create manually the views. The information was not constructed by us manually reading, going through things, and then manually creating things or drawing things on the screen. But in fact, we generated these views out of some specific coding. We took the time to build the tool to afterwards generate the views. And now once you are in that world in which the views are basically cheap, They are a commodity. All of a sudden, a whole new space is being created on the top left. One in which the interesting part of decisions are being left to the human. So let me tell you about how an exploration then can look like. How many of you here heard of COBOL? Heard of COBOL? Okay. How many of you think you have COBOL somewhere in your organization? So about a quarter, right? And the other ones, you just don't know it's there. Now, the thing about this is that we saw there was this, we saw a post from a reputable blog recently talking about a demo from AWS that AWS created with a COBOL sample. So it's called the AWS card demo. And basically, it's actually created by Amazon. So what you see here is, this is now, I am in a so-called, what we call an inspector. So I'm actually looking at a file reference of this folder, AWS card demo. And then I clicked on this notice file, and I can see it's another file reference, and I can see here the contents. That's interesting enough. This file reference, it looks like it has other kinds of views here. So, and that I can basically choose. For example, I can have the details of it, or I can have the hex of it. Okay, now some other things that we can see over here is the fact that they have a few pictures. For example, like this, these are like screenshots from running this COBOL system in their environment, on a mainframe, or at least on a simulation of a mainframe. And then there are also other kinds of pictures, like the flow for an admin. And these are like flows, logical flows. Now, one thing to notice about these ones is that because they have this interesting style from Amazon, and we have this label on top of it, we can safely assume that they were hand-drawn. And the question is this the best we can do? And so if I now go here, for example, right, I can see that there's something called BMS. Here's the thing. We started this 2 weeks ago. We didn't know really a lot about COBOL either. So we said, well, how much can we learn within 2 weeks? And so we basically learned that this BMS is where the screens are being defined, right? So in UI at the time, it was basically just characters. But the most interesting thing in COBOL is that it has this weird thing that there's no distinction basically between data and the program. They kind of overlap. And so a screen is essentially a layout of the bytes that are being basically shown. So we can take a look here. If I look at this BMS, I can see, oh, look, I have syntax highlighting, but I'm in an inspector over that file. Now, of course, code is one way to look at it, but seeing the screen is another way to look at it. So that's kind of interesting. So it already allows me to have some sort of an idea, but I'm still just working with files. It's like, oh, that sounds kind of arcane. So I don't want to work with files. I would like to raise the level of abstraction. So instead of me, I go back to my notebook here. Instead of evaluating this or inspecting this instruction, which allows me to inspect the file system, I'm going to evaluate a model that I just created. I imported the information and built a little model, and now I'm going to browse that model. So I can say, oh, look, I have here multiple of these screens, and so now I can browse through my screens. This is kind of interesting. And then, of course, I can take any of these screens, and if I double-click on it, I'm going to look, and I'm inspecting now one of these screens. And then, of course, I can take a look at the source code if I want to. But, reading COBOL is actually not that comfortable. So much more interesting would be to take a more logical view. So this kind of tells me, well, given this screen, what other interesting programs are there reachable from this screen? And the other interesting thing about COBOL is that you're not calling a function and then you're returning something. You're calling a function, and that function or that procedure there is going to go back into your file. So you have to kind of differentiate between what is the interesting call going forward and the call that comes back, so that you can distinguish between calls and returns. So I can see, for example, here that this screen right? I can see that it's the same screen over here. It actually calling this, it's calling this program, and this program, I can see that this is the source of it. But the other thing I could do is I can go in here and I can click on the arrow, on the exact arrow, and I can see how the programming is being called. This is not just some program, but it's being called in some way. And then, of course, here I get the source code, which is already kind of interesting. But even in the source code, it's not just source code, because why would I just want to be exposed to some raw data, which, by the way, in the case of COBOL, it kind of is, because it literally is a layout of it really is a description of the layout of the memory. So instead, I want to have tools that present information in the way it's comfortable for me. And so every time I see something happening here, I could go and even dive into that place. Because why not? This is what makes it interesting for me. And that is actually not the end of it, because you have here a program, and this program has variables. Now, the variables, if I look at one of these variables, is kind of interesting, because I can have here overlapping variables, because it literally, like, this variable is defined within some other variable, and then, or in some other structure, and if you're overriding the other overstructure, you're literally writing off the inner variable, which you kind of need to make sense of. So if I want to see who is going to inadvertently, go and override my variable, I need to see what other overlapping variables are there. Oh my God! And then I have the variable, and the variable has accesses because I can see. I want to know where these are being used, and they are being used right here. And if I'm going to look inside, I'm going to see that exactly that's what happens. Now, who finds this cool? No, seriously, who finds this cool? Yeah? It's COBOL we are talking about. There is absolutely nothing terrifying about COBOL. In fact, there's absolutely nothing terrifying about any system anywhere. The only thing you have to change is the way you look at it. How many of you here love working with legacy systems? Too few. Think of it. You are the best paid class of people in the world. And you don't love most of your working life. What chance does anyone else have to happiness? We fundamentally have to change this. And here's the cool thing. We can. But it requires you to start thinking about how you spend the largest chunk of your energy. And the first thing you're going to do is you want you to start talking about it. This is literally something that we started 2 weeks ago, a couple of people, and this is where we ended up with. And it's not the only one. Now, perhaps, what's the implication of this? Now, as I said, there are differences in conversations, like what we can enable once tools become changeable, because that's the idea. That's exactly what happened in front of your eyes. I changed the tool while I was working with the tool. It didn't just show me exact things. It showed me lots and lots of little different perspectives all the time, and I chose how to construct those, how to combine those. So, this then, of course, changes conversations, because we can literally talk differently, both among ourselves and with our systems. And so as an example of this, I want to give one, I found this really interesting video. Any of you watched Andrej Karpathy? So he's a reasonably famous AI engineer, and he's doing some excellent video tutorials. So here's one of them about tokenization. Do you know what tokenization is? Okay, so tokenization, right, so most of you do, but for those that don't, tokenization is this little step that you take before you send the content to the LLM. And so now, he's doing really a wonderful thing. So this is actually a 2-hour video in which he actually goes through actually programming a tokenization algorithm pretty much live. And he's doing this programming in a notebook using Python. And but in order to explain what tokenization is, he's using some tools to help with the explanation. So I want to play this one for you at the moment, right now.
Over it a little bit. And let's go to this web app, the ticktokenizer.vercel.app. So I have it loaded here. And what I like about this web app is that tokenization is running sort of live in your browser in JavaScript. So you can just type here stuff, hello world, and the whole string retokenizes. So here what we see on the left is a string that you put in. On the right, we're currently using the GPT-2 tokenizer. We see that this string that I pasted here is currently tokenizing into 300 tokens. And here they are sort of shown explicitly in different colors for every single token. So for example, this word tokenization became 2 tokens. The token 30,642 and 1,634.
So this is what he starts with before he goes on to implement. And after he goes on to implement, it kind of looks like this. So you're basically somewhere, writing some Python code, getting some numbers and some strings, and then continuing further. So now this is a reasonably, fashionable topic. It's an important topic. And he is an excellent presenter. But the best way in which he could make you create a mental idea in your mind was to go out of his development environment somewhere else where there is some sort of an explanation of the overall inputs and outputs. And I said, well, can we do better than that? So I'm now inside our notebook. And in this case, I'm going to use Python here. And what we've done is we took exactly in this case, the tick token, a tokenizer algorithm from OpenAI, and when we wrapped it into our little, with a small wrapper, that also comes up with explanation. So now when I'm executing this, I'm executing Python code, and I get a Python object back. And so now I'm inspecting this Python object, but I still have the different views to it. So I can see, okay, these are all the tokens here, but I also see this perspective, right, which is the visualization that we saw before. But I'm not going away. The visualization comes to me. Now, this is kind of interesting, but what's the implication of this? Because you see, as soon as he finished that broad explanation, he went back and worked with numbers and strings. Can we do better than that? So, yeah, the answer is we can. So here is the next thing is we took his algorithm, the notebook that he built during the demo, and we wrapped that one into a little bit of an explanation. So now when I'm executing this, I get my tokenized view, but now I get a little bit more. Because I also see what kind of merges. In his explanation, he was saying how 2 tokens actually merged with one another. So what happens here is that if I click on this token, I get a merge object back. And this merge object can tell me this is the before and this is the after. So I had 2 tokens before and 1 after. And of course, if I go here, and I can see the before and after. So, but we can go a little step further, because if I now know what all the merges I had in my system, I can now take a look at all those merges, and now I basically have a back-in-time debugger just constructed out of some basic objects. Is this cool? Yes? Okay, great. Now, the question is, how did we build this? Because maybe it's too expensive to do, and this is why people, go somewhere else. Now, this merges view over here, if I now alt-click on it, it actually gets me to the implementation, and the implementation is just a column list. I have 2 columns over here, and I'm defining it, in this case, in Python. And the Python, so the object that I'm inspecting simply knows how to draw itself, but it doesn't draw itself as text because, it's the 21st century. And so we're drawing it as widgets. So we define a widget with column list and 2 columns over here, and that's it. Now, of course, for this kind of visualization over here, it's a little bit more complicated. In this case, it's actually not implemented in Python. It's implemented in the client language here, which in this case, it's Faro. But it's not that complicated either. But just by doing this little thing, once I explained the big thing with the same kind of energy, I could now explain the little things, every little step in my algorithm. They don't have to, nothing in a system must remain, difficult to understand. But then the question is, well, so where are we right now? Because I think, we started in a slideshow, and then we looked at the map, and then we dived into the map. And actually, now we're looking at a notebook. Now, this notebook is actually in a book. And this book documents the environment in which I'm giving you the presentation. And the interesting thing about it, I can take a look at various places. Now, I was mentioning something about Smalltalk, or Faro in this case. And if you want to understand how the syntax looks like, well, here's a sample code. And if you want to know how this code, what kind of constructs are available there, you have an interactive thing right in the book, which is now in the map, which is in the slideshow. But then sometimes you're going to say, well, if I go to one of these if I go to one of these other environments and I say, well, I can see here some sort of a notebook. What kind of shortcuts are available in this one? So I could, of course, right-click here and I can see some sort of shortcuts. But then, you know what? Actually, what if I actually go and inspect this visual thing? And that's exactly what I could do if I wanted to. So I could go here. This case is somewhere else. Where is it? It's probably here. Okay, so this is a little bit more complicated than I wanted it. Okay, I can't show you that. Okay, so, but the conversations, they don't have to be limited to just either code and some rudimentary output, or someone drawing on the whiteboard. We can bring anything that we draw on the whiteboard, and we can put it in our system, in our environment. And that's how we can work with this. And then, of course, for example, any of you have seen things like this? Maybe you recognize some sort of an architecture diagram. Now, this is about, for example, a diagram of a Spring Boot kind of system, and they have microservices over there. Some of them had databases, some of them not. And then we looked at it, and it was 3 years old. Then, of course, but this was the diagram that people used to describe the system. But that was not the most interesting thing that they could have shown us. So if we went and built a tool that would draw the same diagram, we could see something like this. Okay, so this is not so visible there. But when we highlight, for example, I'm now going through one of these, and I can see that I'm clicking right here, and I can see that there is a red component to my right, and there's a red component to my left. And the red means I am using that, but I would like all those that I'm using to be to my right. And so now it means that I have a cycle over there. But this cycle they didn't know about, because it's too hard to see if you're going to read the code. And so the question is, well, how did we build this? Well, of course, this is, again, interactively buildable. But the more interesting is to take a look at how a dependency in Spring Boot actually appears. Because a dependency is something, you have a component over here, and you have some sort of, at some point you're going to say template exchange, template post, or something like this, and then you're going to have a URL there. And that URL is going to be resolved on the other side on a REST controller, which is annotated with the path. And in that path, we have to figure out that /transaction is the same as the transaction we had there. But if I can tell my tool to actually look at that string, of those strings, it can actually infer those dependencies. Of course, a generic Java tool will not know about them. But my tool that knows about the library that I'm using will know about it. So the construction of the diagram is actually very cheap. And that's the differentiator. And once you have something like this, you can put it in documentation because it's already generated. So that idea of documentation going out of sync with the code, the way to address it is to not have documentation out of sync in the first place. These are not two artifacts. The one that we see here is something that is generated out of the core. And this basically gets us to this idea of model centricity. We have a single model, a single source of truth. Everything else are just perspective onto that. Of course, those perspectives add new semantics, but that's why it's important to be able to understand what kind of semantics, what kind of interpretation, what kind of bias do they bring. Then, of course, the question is, somebody has to build those tools. But how do you build those tools? And this gets us to the synthesization part. So what I have here is I thought, well, let's do something that is maybe not so codey a little bit. So I have here, I'm going to say, I want to create a tutor that works with OpenAI. And here I have a post, which is, I'm talking here about there are at least 2 ways to use LLM for supporting understanding of software systems. A, use LLM to generate summaries. B, use LLM to generate tools with which you generate summaries. And I go on here a little further. So what I will do here is I will instantiate a post variable. In this case, it's going to be a string. And I can see that string over here. And then I'm showing you here a tutor. I'm telling the tutor that there's going to be a variable, that I want to pass this variable into the tutor, so I'm doing it right here, and then I'm creating a chat. And now I'm inspecting here a chat. This is a live chat with OpenAI, and see if that works. Now, the interesting thing about this chat is that it has the instance, so it already knows about the post that I gave it, and now I can have a conversation with it. For example, I can say, create a title for the post. And now if I execute that, hopefully, things happen. Let's see if the gods of the Wi-Fi and of GPT are agreeing with us. Okay, they are not, are they? So, something is wrong in this particular demo. Okay. Let's actually go and start from scratch. What I will do, I'm going to start this again. Let's see if this works. Create a title for the post. I'm going to do it. OK, so this looks better. So now the assistant is telling me, OK, it's thinking about it and says, well, title suggestion for the post, harnessing this. Now, this is kind of interesting. Now, this is a generic browser. This is a generic view. And you're probably seeing this kind of view all the time. So the thing about this is that, well, I don't want to be exposed through generic views with anything in relation to my computer, including a chat. So what I would do here is, if I have the ability to inspect any one of these messages. So this is a message, and you can see this is a generic OpenAI action threat message. And so I can go and say, well, you know what, reify this. That is, create a dedicated class. And I can say, well, create me a post message here, and I want also a post tutor, and put it into a package called GOTO. And so now when I do this, next time I'm inspecting it, I get a post message. I changed that object. It's not exactly the same. And then I can go and say, you know what, let's reify this action because I like the interaction. I gave you an instruction and you gave me back an answer. And I say, well, create the title over here. And I say, okay, I need to put some more strings. And I have an editor over here and it kind of looks good. I'm fine with this. So what happens now, my chat extended. I have a new action over here. I can go and ask it to create a title. So, for example, now if I go here and I do this and I do it again, now I didn't have to type create title again. It did it, and now, and the thing is that it sent in the JSON that I'm looking inside, I'm now looking inside my message, and I see, well, there's an action like this, and I'm also pasting the whole post in there, and I can see, oh, look, it comes back with the title. So it's kind of nice. But then I can say, well, you know what? Correct the grammar, the post grammar now. And once you do this, put the value in post property. So now if I do that, I'm sending now the message, and now it will give me back a value back at some point. So now it give me this, right? And oh, look, it put the value in the post message. Great. But now if I look at this, oh, that's not nice, because now I have some large text on the left and I have some large text on the right. I'd rather want to see a diff view. So to this end, what I will do is I will now inspect the message, this little tiny thing that got back. And what I'll say, well, actually, let's go and create the view over here. I'll say, well, let's create a diff view and I'm going to say, I'm going to pass here a view. This is like a stream, but of widgets. I'm going to annotate this a bit. I'm going to say return a view. I'm going to say here, I want a diff view. I'm going to say post diff, and this one has a from, and the from is given the message. I can go to the chat, and the chat has content. What is it? Instance content. Actually, probably like this. Actually, I don't know. So at this point, what I will do is I will just go over here, inspect my chat. Now I can see, oh, look, the chat already knows how to paste the instance. Oh, so it says pipeline over here. Great. So I can say pipeline. The pipeline has an instance view. I'm now looking at how is this one created. Oh, there is instance over here. Great. Now I'm looking, oh, there's a content. It's wrapped even more. Great. This one, there's apparently a content over there. So I can just say content. And now I get to my string. Excellent. So I go back to my little thing over here when I'm creating this, and I say from, and then I say to, and then I say, well, self, and this one has a content JSON, and then I say, well, at post. And when I do at post, and then I save this, a new thing appears, and then I'm gonna annotate it with GTLLM view, and now next time I'm gonna look at this view, a new post view will appear, and now I will see the diff between the correction and the original one. And I didn't have to wait for someone to create me that interface. I created it myself. But think about this, because I created this is exactly the same development environment I was looking at the COBOL. What do they have to do with each other? Here's the thing, they are the same. And all this narrative that you have to have different kinds of tools for different kinds of jobs is just wrong. They don't exist. Those differences, they don't exist. And once they don't exist, you can combine them in many, many different ways. And that's why we talk about little tiny composable tools. So here I have lots of different objects. And now if I look at them through just this rigid view, like variables and values of an object, it's just, they're bland, they're not interesting. I don't know the difference. But if I look at them like this, with dedicated views, all of a sudden I can create interesting narratives. And this gives us into a completely different world. It looks very similar, but it's actually not. Now, one thing I asked you at the beginning is if you love working with legacy systems. Because we should have a talk a little bit about the system. The system isn't just something that transforms inputs into output. A system encodes knowledge. And it typically encodes the core knowledge of an organization. If you cannot tap into that knowledge, you're basically hindering your ability to create value. But even worse is that we have to fix this feeling we have when we are inside of a system. And that's why we introduced a new word in our vocabulary. And this word is called feenk, from feel and think concomitantly. Because the way we feel is as important as the way we think. And it's time we start investing in it. Now, this will take time. And it takes in new kinds of skills. And that's why we put together a little environment in which you can train your skills and be aware that this idea exists, this possibility exists, and then go and start talking about how you read code. Thank you very much.